So in this video, what I want to do is I'm looking at finding the area of compound shapes. And basically what we want to do whenever we have a compound shape is that we want to split up that compound shape in as many regular shapes that we know. For example, semicircle and a big rectangle is what I could get when I do that one split. So let's talk about the measurements on hand here. So in terms of the measurements that we're looking at, remember the entire distance from here to here is actually 13 feet. But we do realize that this piece is 4 feet. Therefore, if I take the 13 feet and I subtract that 4 feet from it, okay, then the remaining would have been 9. This is going to give me 9, which means that this right here, it means that this piece is 9 feet. So this diameter of this semicircle is 9 feet. So let us go about finding the area of that semicircle and then finding the area of the rectangle. So the area of the semicircle, I'm going to do that to the left. Remember, the area of the semicircle comes from the area of a circle, which is pi r squared. But because it's a semicircle, I'm going to take a half of it. So basically, I need r. We do have the diameter, which is 9. So if I take that diameter and I divide it by 2, so 9 divided by 2 will give me 4.5. This is actually my radius. So the radius that we're dealing with is actually 4.5 feet. So let's plug this in our formula. So it's going to be a half times pi. We're using pi as 3.14 times 4.5 squared. So all we're going to do is to put that on to get that area of that semicircle. So when we do this, we're actually getting 31.9.7925. So basically, this is approximately 31.8, and this is the three significant figures, square feet. So that's for this part right here. Now we're about to find the area of the rectangle. If you take a look carefully, the area of the rectangle would have been this blue part that I'm shading here, this blue section, right? So it's that blue section that I'm looking at. Also, in terms of the dimension that we have a 8 by 13. Let's put it on the right side. So the area of any rectangle can be found by multiplying the length times the width. So in this case, it's 13 times 8. So we want to put that on, 13 times 8. And it's going to give us about 104. And this is square feet. So what do we really have? We do have, for this part, we have 31.8 square feet there. And in this section, we have 104 square feet. Let's add them together. So the area of the figure is going to equal to 31.8 plus 104. And we're looking at 135. So this is a total of 135.8. square feet. All right, so that is our first question there. Let's take a look at another one. For this second diagram that we have looking at, um, we're still going to try to find the area of the entire figure. We do notice that we already have three shapes that we're looking at. We have a rectangle here, we have a triangle there, and we have a semicircle here. Now, we're going to find the area of the triangle, then the area of the rectangle, and then the area of that semicircle. All right, let's get into it. All right, so the area of any triangle, we actually can find this by having half its base times its height. In this case, the base is basically any side that it is sitting on. In this case, it's 20. The height is this perpendicular distance here, which is 16. All we're going to do is we're going to just multiply these numbers. So it's a half times 20 times 16, and that's about 160. So we do have 160 square centimeters for that. So let's take a look at the area of the rectangle. The area of the rectangle is length times width. And the length is 20, the width is 15. So we're looking at 20 times 15, and this is going to give us 300 centimeter square. Let me write that over. All right, so we have 300 centimeters square for that. Lastly, we're going to be looking at the semicircle. Now, remember that this is 20 because it was a rectangle. So this length is equal to this length down here. It's 20. But remember that the radius of this is to take the 20, which is the diameter, divided by 2. It's going to give us 10. So the radius is actually 10. Okay? So the radius is 10. So we mean that this distance from here to here is actually 10. So we are aware that we could now find the area of this semicircle. Area of semicircle is equal to a half pi r squared. And so this is going to be a half times pi, which is 3.14 times r, which is 10 square. So all we're going to do is to put this on our calculator. And this will give us about 157 square centimeters. So there it is that we have those measurements looking on. So in terms of finding the area of the whole figure, it's going to equal to 160 plus 300 plus 157. Let's put that all together. We're getting some 617 square centimeters. There we go. Let's take a look at another question. This third and last example of finding the area of component shapes that we're going to be looking at. We have this shape here. So we could do a number of things with it, but I'm going to cut it into two shapes that we're very familiar with. So I'm going to take it along here. I'm just going to extend this line here. And there are multiple ways to do this, but you could break it up in the shapes that you want. I'm seeing where I would love to take this into a rectangle with a triangle. So that one line there would have created shape one, which is a rectangle here, and then shape two, which is a triangle on top. So those are two regular simple shapes that we could easily find the area of. So let us put on some numbers. Now, as it for the rectangle, the width, as you could see, is 5 meters and the length is 40. So we have that. So let's put that into action. So the area of that rectangle that we're looking at, it's going to equal to length times width, and this is 40 times 5. This is going to give us 200 square meters. With the triangle, the area of the triangle can be found by using this formula, half times base times height. So we're looking at 25 is not the height of the triangle, 40 is not the base. So we're going to have to put the numbers in the right order. And let us put it together. Now let's look, we're trying to work on the base first. So if you take a look here, if I remember that this here is 12. So the entire line here is 40. So if I take 12 from that 40, I'm going to get 28. And this is suggesting that this red line here is 28 meters long. So let's put that on. Now let's take a look at the height. Now this entire line here all the way down is 25. But remember that this is also 5. So the remaining piece here is to take the difference between the two numbers. So it's going to be 25 minus 5. It's going to give us 20. So it means then the height that we're looking for is 20 meters. So this is the height and this is the base. So let's put it in. So a half base times height is a half times 28 times 20. All we got to do is to take our calculator and then just work these out. Let's put it in. A half times 28 times 20, and that's about 280. So this is giving us 280 square meters. Remember, we want to find the area of the entire shape. So I'm just going to drop it right here, that the area of the figure is to add the area of the two shapes that we got, which is 200 for the area of that rectangle, plus 280 for the area of that triangle. So finally, we're looking at 480 square meters.